Hello, welcome to the next section in our FE exam review course. In this section, we are going to be doing a review of zero force members. This concept is very important for statics and definitely for your FE exam. So these practice problems are going to help you become familiar with how to identify zero force members. As always, make sure that you attempt the problems yourself before you look at the solution. But when you're ready, let's go ahead and begin. So when we are identifying zero force members on a truss, our analysis is going to be based off of two principles. In this lecture, we're going to be doing 4 problems. The first 2 are going to be helping us understand principle 1, and then the last 2 are going to help us understand principle 2. So that being said, let's go ahead and take a look at principle 1 so that we can solve our first question. Okay, so here is principle 1. If a truss joint is formed by only 2 noncollinear members, any of those members that has no external load, support reaction, or force being transferred along its line of action is a zero force member. So if we take a closer look, we can see that it's talking about noncollinear members. In this case, noncollinear means members that don't share a line of action. So an example of collinear members would be AB and BC. As you can see, they're both along this horizontal line of action. Same thing for DE and EF. So then non-collinear would be members like EF and FC. As you can see, they have completely different lines of actions. This one is vertical and this one is horizontal. So now that we understand the difference between collinear and non-collinear, for principle 1, we are interested in truss joints formed by 2 noncollinear members, and then at that truss joint, any of those members that have no external load, support reaction, or force member being transferred along its line of action will be our zero force members at that joint. So after taking a closer look at our principle, now let's go ahead and apply it to our question 1 to find the zero force members in this truss. So in this case, let's start off by finding where we have truss joints with 2 noncollinear members. In this case, looks like joint F is going to match that criteria. So if we take a closer look at joint F, we can see that neither member EF or member FC have an external load, a support reaction, or any other force acting along those lines of actions. So that tells us that both of these members are zero force members. So I went ahead and crossed those out, as you can see here. However, we still have one more zero force member on this truss. So if we take a look at joint D, we can see that it is another joint formed by 2 noncollinear members. So this is going to be another place where we can find a zero force member. However, remember, our only zero force member at this joint is going to be the one that has no external load, no support reaction, or no other force acting through it. So in this case, member DE is going to have a force acting through it. It is going to have this 45 kilonewton horizontal force. However, DA is not going to have a force acting through it, as we can see here when we look at joint D. So therefore, this is going to be our third zero force member. So therefore, all of the zero force members on this truss are going to be FC, FE, and DA. So now let's go ahead and move on to question number 2. Moving on to question number 2, now we have a truss that looks completely different. However, like I mentioned at the beginning of the lecture, this question can also be solved using principle 1. So let's go ahead and see how principle 1 applies to our new truss. So remember, for principle 1, we're interested in joints that have 2 noncollinear members. So let's go ahead and take a closer look at our truss. In this case, we can identify that joint E is going to be one of the cases we're interested in. It has 2 noncollinear members, as you can see here. This is a different configuration that we saw earlier, but it doesn't matter. It's still 2 noncollinear members, even if this one is diagonal and this one is horizontal. In this case, neither of the members, ED or EB, have an external load or a support reaction on it. So therefore, we can identify these two as zero force members. So one thing to keep in mind when finding zero force members on a truss is that when you find a zero force member and you cross it out, you can basically analyze the rest of the truss for zero force members as if these were not present. We can basically eliminate them. So now that we have eliminated member DE, in this case, joint D is going to become one of those cases where we have a joint formed by two non-collinear members. So in this case, member DB is going to have this 5 kip force acting through it, as you can see here. However, member DC does not have a force acting through it or a reaction. So in this case, member DC is going to be a zero force member as well. We have one more zero force member on this truss. In this case, if we take a look at joint A, we have another case where a joint is formed by two non-collinear members. So in this case, member AB is going to have this reaction force from the roller, the horizontal reaction, acting through it. So that is not going to be a zero force member. However, member AC does not have a reaction or an external force acting through it. So that is going to be our zero force member at this joint. In this particular case, as you can see, there is a pin support here, which means it's going to have a horizontal and vertical reaction. However, this diagonal member is going to take both of those reactions, because remember, a diagonal force is broken down into horizontal and vertical components. That's what we've done in the previous sections. So therefore, this diagonal member is enough to handle the reaction forces at this pin. And therefore, that further confirms that these two members are zero force members. So therefore, the answer to this question is all the zero force members are ED, EB, DC, and AC. So now let's go ahead and move on to question number 3. Moving on to question number 3, now we have a new truss. Like I mentioned earlier, questions 3 and 4 can be solved using principle number 2 of identifying zero force members. So let me go ahead and show you what principle 2 is. So principle 2 states, if a truss is formed by 3 members and 2 are collinear, the non-collinear member is a zero force member if no external load, support reaction, or force acts along its line of action. So when I went over principle 1, I explained the difference between collinear and non-collinear. In this case, we're interested in joints with 3 members where 2 of them are collinear. So for example, in this drawing, AB and BC are collinear members, and then the non-collinear member is BD. So what principle 2 is saying is that when we have cases like these, that third non-collinear member is going to be a zero force member as long as there's no reaction force or external load acting through it. So in this drawing, the zero force member would be DB. That third non-collinear member doesn't necessarily have to be perpendicular to the two collinear ones either. In this example here, member FH would also be a zero force member as long as there's not any support reactions or external forces acting through it. So now that we've gone over principle 2 and how to apply it, let's use it to solve question number 3. So if we take a look at this truss, utilizing principle number 2 for identifying zero force members, we are looking for joints formed by 3 members where 2 are collinear and 1 of them is non-collinear. So let's go ahead and start off with joint H in this case. As you can see, we have these 2 collinear members, and then HC is going to be our non-collinear one. In this case, it looks like there's no force or reaction that is going to be acting through HC. So that is going to be our first zero force member for this truss. Next, we can move over to joint F. As you can see, it has 3 members and 2 of them are collinear. Our third non-collinear member is going to be FD. In this case, member FD does not have any forces or reactions acting through it, so that is going to be a zero force member as well. So like I mentioned in the previous problem, now that we determined member FD to be a zero force member, we can continue to analyze the truss as if this member isn't here. In this case, if we eliminate this member, we're going to have another scenario here at joint D with two collinear members, CD and DE, and then a third non-collinear member, DI. In this case, this third non-collinear member, DI, does not have a reaction or force acting through it, so it is also going to be a zero force member. In this case, that is going to be all of the zero force members for this truss. So we have member HC, FD, and DI. As you probably noticed, joint B has two collinear members and a third non-collinear member. However, keep in mind that this 8 kip force is going to affect our member BG, as you can see here. So therefore, that would not be a zero force member. Moving on to question number 4, we have one more truss, and in this case, this one can also be solved by using principle 2. So let's go ahead and start taking a closer look. In this case, let's start off by looking at joint B here. So here's our two collinear members, and then our third non-collinear member. So in this case, that third non-collinear member EB has no support reaction or external force acting through it, so it is going to be our first zero force member. Now that we've eliminated member EB, joint E is going to turn into a scenario that applies to principle 2, because now we have AE and EF as our two collinear members, and then member EC is that third non-collinear one. In this case, there's no reaction or external force acting through it, so it is another zero force member. Eliminating member EC is then going to turn joint C into another principle 2 scenario. Now we have these two collinear members, and then member CF is our third non-collinear member. In this case, member CF has no external load or support reaction either. That is also going to be a zero force member. Continuing with the pattern for this problem, eliminating member FC is going to turn joint F into another principle 2 scenario. In this case, here's our two collinear members. Our third non-collinear member is FD. There's no support reaction or external load acting on it, so it is going to be our final zero force member for this problem. This brings us to the end of this lecture on zero force members. I hope that it was very useful. I remember when I was a freshman taking statics, struggling with zero force members, so I know that it can be kind of tricky. The principles for learning zero force members are not complicated, but they can be tricky if you try to learn them just by reading the principle and memorizing it. I think it's better to learn them with examples like we did in this video. That being said, I hope it was helpful. When you're ready to move on to the next lecture, we are going to be covering truss analysis. So I'll see you there.